Let's see question number 26. If matrix A is this one, then verify that A square plus A equal to A into A plus I, where A is 3 by 3 unit matrix. Let's see the solution of this one. Matrix A equal to here 1, 2, 0, 0, 1, 1, minus 1, 3, and this is the 1. Therefore, A square equal to matrix A into matrix A. 1, 2, 0, 0, 1, 1, minus 1, 3, and 1. So here will be R1, R2, and R3. This is R1, this is R2, and this is R3. This is C1, this is C2, and this is C3. So the multiplication of this one will be R1 into C1 and R2 into C2 and R3 R1 into C3. Here will be R2 into C1, R2 into C2, and R2 into C3, and here will be R3 into C1, R3 into C2, and R3 into C3. After there is no problem to understand up to this step. This is the another method. So we find out R1 into C1, R1 into C1 equal to, we get here, we write down here 1, 0, and minus 1, and C1 will be what? C1 we write down here 1, 2, 0. So the multiplication of this one will be what? 1 into 1, so 1 into 1, okay, plus 0 into 2, and plus minus 1 into 0. Then we get here 0, 0, and we get here 1. Therefore, R1 C1 equal to what? 1. So we continue, and we get this one. This is the 1, okay. Similarly, R1 C2, it means that R1 C2, then 1 into 0, 0 into 1, and minus 1 into 1. After that we add these multiplication, then we get 1 into 0 equal to 0, 0 into 1 equal to 0, and minus 1 into 1 equal to minus 1. So here will be minus 1. After there is no problem to understand up to this step. Similarly, R1 C3, it means that 1 into minus 1 equal to minus 1, 0 into 3 equal to 0, and minus 1 into 1 equal to minus 1. So here will be minus 2. Similarly, we find out this one, then 2 into 1 equal to 2, 1 into 2 equal to 2, and 3 into 0 equal to 0. So here will be 4. R2C2, it means that 2 into 0 equal to 0, 1 into 1 equal to 1, and 3 into 1 equal to 1. So 1 plus 3 equal to 4. And R2C3, it means that 2 into minus 1 equal to minus 2, 1 into 3 equal to 3, and 3 into 1 equal to 3. So here will be 6 minus 2 equal to 4. Hope that there is no problem to understand up to this step. Similarly, R3 C1, so 0 into 1 equal to 0, 1 into 2 equal to 2, and 1 into 0 equal to 0. After the addition we get what? Then we get here 2. R3 C2 will be 0 into 0, 1 into 1 equal to 1, and 1 into 1 equal to 1. So here will be 2. And R3 C3 equal to 0 into minus 1 equal to 0, 1 into 3 equal to 3, and 1 into 1 equal to 1. So 3 plus 1 equal to 4. So according to this process, we get a square equal to this one. Hope that there is no problem to understand up to this step. So here will be a square plus a will be 1 plus 1 equal to 2. So we write down here 2. Okay. 2 plus 4 equal to 6. Okay. 0 plus 2 equal to 2. And 0 plus minus 1 equal to minus 1. 1 plus 4 equal to 5, and 1 plus 2 equal to 3, and minus 1 plus minus 2 equal to minus 3, 3 plus 4 equal to 7, and 1 plus 4 equal to 5. So a plus I, so I will be here, write down. I means identity matrix or unit matrix according to the question. The order of this unit matrix is 3 by 3. So we write down here 1, 0, 1, and 0, 1, 0, 0, 0, and this is the 1. So here will be a into a plus I. After the proper multiplication we get here 1, 2, 6, 2, and minus 1, 5, 3, and minus 3, 7, and 5. So from working it is clear, from working it is verified that from working it is verified. Hope that there is no problem to understand the solution as well as the explanation of the solution of this question. If you have any doubt, write into the live chat box. I will try my level best to clear your doubt. Live chat box is open to all of you to get uh, clearance of your doubt on a spot. Let's see question number 27. If matrix A equal to this one and order of this one is 2 by 3 and matrix B equal to this one, order of this one is 3 by 2, then ask us verify that transpose transpose of A equal to A. Transpose of A into B equal to transpose of B into transpose of A. Transpose of K into A equal to K into transpose of A. So let's see the solution. We find out the transpose of A. So transpose of A here will be, we interchange the row into column. So first row will be first column. So here first row is 0, minus 1, 2. Therefore first column will be 0, minus 1, 2. Second row is 4, 3, minus 4. Therefore second column here will be 4, 3 and minus 4. Again we transpose this one. Then we write down here transpose of A. Then here first row will be first column. So 0, 4. Second row is the second column. Therefore minus 1, 3. Third row is the third column and this is 2, minus 4. So which is equal to what? A. So this one is verified. After there is no problem to understand up to this step. Now we find out A into B. So let's see, order of A is 2 by 3 and order of B is 3 by 2. So number of column of A is equal to the number of rows of B. Therefore product of A and B is possible and order of A into B will be 2 by 2. So let's see here, A dot B or product of AB equal to, we write down here 0, 4, minus 1, 3, 2, minus 4 into here will be 4, 1, 2, 4, 1, 2 and 0, 3, 6. So the multiplication here will be first row by first column, then we get 0 into 4 or we write down here order of this one will be 2 by 2. So 0 into 4 plus here will be minus 1 into 1. So minus 1 into 1 plus we write down here 2 into 2. And for the second element here will be 0 into 0, 0 into 0 plus here will be minus 1 into 3 plus here will be 2 into 6, 2 into 6. So that there is no problem to understand up to this step. For the element of the second row, we consider about this one 4 into 4. So we write down here 4 into 4 plus 3 into 1 plus minus 4 into 2. After there is no problem to understand up to this step. For the second element here will be 4 into 0 and here will be plus 3 into 3 plus we write down here minus 4 into 6. After there is no problem to understand up to this step. So here next step will be 0 plus minus 1 plus 4, 4 minus 1 equal to 3. So here will be 0 minus 3 plus 12. 12 minus 3 equal to 9. And 16 plus 3, 19 minus 8 equal to 11. And 0 plus 9 minus 24. So here will be minus 24 minus 9 equal to 15. So minus 15. Observe there is no problem to understand up to this step. Therefore, AB equal to this one. So the transpose of AB here will be transpose of AB will be first row will be the first column. So here will be 3 9. Second row will be second column 11 minus 15. Observe there is no problem to understand up to this step. Now we find out transpose of B. So transpose of B here will be transpose of B. First row will be the first column. So here will be 4 0. Second row will be second column. So here will be 1 3. And third row here will be third column. So here will be 2 6. And transpose of A equal to first row will be first column. So here will be 0 minus 1 and 2. 4 3 minus 4 3 and this is the minus 4. After the multiplication of transpose of B into transpose of A, here will be transpose of B into transpose of A. Let's see, here will be first row according to the first column. So 4 into 0 equal to 0. 1 into minus 1 equal to minus 1. So here will be minus 1. 2 into 2 equal to 4. So here will be plus 4. First row by the second column, then we get here 4 into 4 equal to 16 and 1 into 3 equal to 3 and 2 into 4 equal to minus 8. Observe there is no problem to understand up to this step. Second row by first column, then we get 0 into 0 equal to 0 and 3 into minus 1 equal to minus 3 and 6 into 2 equal to 12. Second row by second column, then we get here 0 into 4 equal to 0 and 3 into 3 equal to 9. So we write down here plus 9 and 6 into minus 4 equal to, we write down here minus 24. So we get here what? Equal to 3 and here will be 11 and here will be 9 and here will be minus 15. So let's see here, transpose of AB is equal to the transpose of B into A. Similarly, we can prove 3 or verified. So this one is also verified. Similarly, we can verify this one. So it is very easy. K into A. So each element multiplied by K. So we write down here K into A. So each element multiplied by what? K. Then we get 0 minus K and 2K, and here will be 4K and here will be 3K and here will be minus 4K. So the transpose of this one will be again multiplied by the transpose. Transpose of this one will be what? Transpose of this one will be 0 minus K and 2K. Here will be 4K, 3K and minus 4K. Observe there is no problem to understand up to this step. So K into transpose of A. So this is the transpose of A. When this one is multiplied by K, then we get the same term K into K into K into K into K into K. So this one multiplied by K into transpose of A. So both are same. 0 minus K, 2K, 4K, 3K and minus 4K. So this is also verified. Observe there is no problem to understand the solution as well as the explanation of the solution of this question. If you have any doubt, write into the live chat box which is open to all of you. Let's see question number 28. If matrix A equal to this one, matrix B equal to this one, then verify that transpose of 2A plus B equal to transpose of 2A plus transpose of B. Second, transpose of A minus B equal to transpose of A minus transpose of B. Let's see the solution. So we find out transpose of A and transpose of B first of all. So transpose of A equal to, here will be 1 2 4 1 and 5 6, and transpose of B equal to 1 2 and 6 4 and 7 3. Observe there is no problem to understand up to this step. Now we find out 2a plus b. So here 2a equal to multiplied each term by 2, then we get 2, 8, 10, 4, 2, 12 plus b equal to 1, 6, 7, 2, 4, 3 equal to here 2a plus b equal to here will be 2 plus 1 equal to 3, 4 plus 2 equal to 6, 8 plus 6 equal to 14, 2 plus 4 equal to 6, 10 plus 7 equal to 17, and 12 plus 3 equal to 15. And transpose of this one equal to 2a plus b, transpose of this one equal to 3 6, 14 6, 17, 15. 2 times of the transpose of a equal to here will be 2, 4, this one, 8, 2, 10, 12. And transpose of b equal to 1, 2, 6, 4, 7, 3. Therefore, 2 times of the transpose of a plus transpose of b equal to here will be 2 plus 1 3, 8 plus 6 14, 10 plus 7 17, 4 plus 2 6, 2 plus 4 6, 12 plus 3 15. Therefore, we can write down here transpose of 2a plus b is equal to the transpose of 2a plus transpose of b verified. So this is verified. After there is no problem to understand the solution as well as the explanation of the solution of this question. Similarly, we can verify this one. Similarly, we can verify transpose of a minus b is equal to transpose of a minus transpose of b. After there is no problem to understand the solution of question number 28 as well as the explanation of the solution of this question. If you have any doubt about the solution or explanation of the solution, write down the live chat box which is open to all of you. I will try my level best to clear your doubt on the spot. Let's see question number 29. In this question, ask us that transpose of A into A and A into transpose of A are both symmetric matrices for any matrix A. After there is no problem to understand the question. Let's see the solution. Let matrix A is 1, 2, 3 and 4. Therefore, the transpose of A will be first row will be first column, so 1, 3 and 2, 4. Second row will be second column. After there is no problem to understand up to this step. Now we find out A into transpose of A, and here will be what? 1, 3 multiplied by the corresponding element of 1, 3, then we get here 1 plus 9, and 1, 3 multiplied by the corresponding element of 2, 4. Therefore, here will be 2 plus 3, 4 is 12. 2, 4 multiplied by the corresponding element of 1, 3. Then we get here 2 plus 4. 2 plus 4, 3 is 12. And 2, 4 multiplied by the corresponding element of 2, 4. Then we get here 4 plus 16. 4 plus 16. Equal to this one will be 10 and 14, and here is 14 and 20. After there is no problem to understand up to this step. Now we find out transpose of A into A. So we write down the transpose of A: 1, 3, 2, 4 into A, which is 1, 2, 3, 4. Therefore, the product of this one will be 1, 2 multiplied by the corresponding element of 1, 2. Then we get here 1 plus 4 and 1, 2 multiplied by the corresponding element of 3, 4. Then we get 3 plus 8 and 3, 4 multiplied by the corresponding element of 1, 2. Then we get here 3 plus 8 and 3, 4 multiplied by the corresponding element of 3, 4. Then we get here 9 plus 16. Of that there is no problem to understand up to this step. Therefore, the transpose of A into A equal to here will be 5, 11, 11, 25. After there is no problem to understand up to this step. So we suppose here transpose of A into A equal to X. Therefore, transpose of X here will be transpose of this one, therefore here will be first row will be first column, so transpose of A into A, therefore the transpose of this one, so 511 will be the first column and 1125 will be the second column. After there is no problem to understand up to this step, and suppose A into transpose of A into A equal to X, therefore the transpose of X equal to this one, and A into transpose of A equal to suppose Y, therefore the transpose of Y will be 10 14, and this one will be 14 20. After there is no problem to understand up to this step. So let's see here, X minus transpose of X equal to, let's see what will be this one. So this is the X, then we get 0, therefore X and transpose of X are symmetric. And X equal to what? X equal to transpose of A into A, and X dash equal to transpose of this one will be A into transpose of A, therefore R here will be what? Symmetric. Of that there is no problem to understand the solution as well as the explanation of the solution of this question. So both are symmetric to each other for any matrix A. If you have any doubt to understand the solution as well as the explanation of the solution of this question, then write into the live chat box, which is open to all of you. I will try my level best to clear your doubt. Let's see the question number 30. In this question, let matrix A and matrix B be a square matrices of the order 3 by 3, is AB square equal to A square into B square, give reason. So this question is based upon the property of the matrices. If both A and B are the inverse to each other and the product of A and B is the identity matrix, then this one is the true. So let's see the solution. So here AB square equal to AB into AB, and the order of this one is 3 by 3. So here will be A into A into B into B. Order of each matrix is 3 by 3, and therefore here will be A square into B square, and this is possible. This is possible if A into B equal to B into A. So, hope that there is no problem to understand the solution of question number 30, which is based upon the property of the matrices. If you have any doubt, write into the live chat box, which is open to all of you, and I will try my level best to clear your doubt on a spot. Let's see the question number 31. So that if A and B are square matrices such that AB equal to BA, then A plus B whole square equal to A square plus 2AB plus B square. Let's see the solution of this question. A plus B whole square equal to A plus B into A plus B equal to A square plus AB plus BA plus B square. From question it is clear that AB equal to BA. Therefore, here will be A plus B whole square equal to A square plus AB plus instead of BA, AB plus B square equal to here will be A square plus 2AB plus B square proved. Of that there is no problem to understand the solution of this question. If you have any doubt, write into the live chat box, which is open to all of you. Let's see the question number 32. Let A equal to 1, 2 elements of A along row minus 1, 3. Elements of matrix B along first row 4, 0. Along second row 1, 5. Element of matrix C along first row 2, 0. Along second row 1, minus 2. In this question, ask us so that A plus B plus C equal to A plus B plus C, and 32 has following questions: A, B, C, D, E, F, G, H and I. Let's see the A. So first of all we find out BC. The order of B is 2 by 2 and order of C is also 2 by 2. Therefore B and C is confirmed for addition. Therefore here B plus C will be 4 plus 2 equal to 6, 1 plus 1 equal to 2, 0 plus 0 equal to 0, and 5 plus minus 2 equal to 3. Of that there is no problem to understand up to this step. Therefore here A plus B plus C equal to the order of A is 2 by 2 and the order of B plus C is also 2 by 2. Therefore A and B plus C is confirmed for the addition. Therefore 1 plus 6 equal to 7 and minus 1 plus 2 equal to 1 and 2 plus 0 equal to 2, 3 plus 3 equal to 6. Now we find out A plus B. A plus B equal to order of A is 2 by 2 and order of B is 2 by 2. Therefore A plus B is confirmed for addition. 1 plus 4 equal to 5, minus 1 plus 1 equal to 0, 2 plus 0 equal to 2 and 3 plus 5 equal to 8. Order of A plus B is 2 by 2. Therefore A plus B plus C equal to order of C is 2 by 2 and order of A plus B is 2 by 2. Therefore A plus B plus C is confirmed for addition. Therefore 5 plus 2 equal to 7, 0 plus 1 equal to 1 and 2 plus 0 equal to 2 and 8 plus minus 2 equal to 6. So from working it is clear that A plus B plus C equal to A plus B plus C. Proved. After that there is no problem to understand this solution. Similarly we can solve B, C, D, E, F, G, H, I. I leave this for classwork to all of you. Let's see question number 33. If matrix A equal to cos theta, sin theta minus sin theta cos theta, then show that A square equal to cos 2 theta sin 2 theta minus sin 2 theta cos 2 theta. Let's see the solution of this question. A square equal to A into A equal to cos theta minus sin theta and cos theta. The order of this matrix is 2 by 2. Into again we write down A cos theta minus sin theta and cos theta. The order of this matrix is also 2 by 2. Column of this matrix which is 2 equal to the row of this matrix which is also 2. Therefore these two matrices is confirm for multiplication, and order of the a square will be 2 by 2. So let's see here, first row along first column, then we get cos square theta plus minus sin square theta equal to cos square theta minus sin square theta. Cos square theta minus sin square theta. First row along second column, then we write down here cos theta into sin theta plus sin theta into cos theta. After there is no problem to understand up to this step. Second row along first column, so minus sin theta into cos theta equal to minus sin theta into cos theta plus minus minus, so we write down here minus sin theta into cos theta, and second row along second column, then we get minus sin theta into sin theta equal to minus sin square theta, cos theta into cos theta equal to, we write down here plus cos square theta. Of that there is no problem to understand up to this step. Now we recall the formula of sin 2 theta and cos 2 theta. Sin 2 theta equal to 2 sin theta into cos theta, and cos 2 theta equal to cos square theta minus sin square theta. Therefore the next step here will be, which is equal to the a square equal to cos square theta minus sin square theta equal to cos 2 theta, cos theta into sin theta plus cos theta into sin theta equal to 2 cos theta sin theta equal to sin 2 theta. Similarly this one we take minus common, then we get minus 2 sin theta cos theta, therefore here will be minus sin 2 theta, and here also cos square theta minus sin square theta equal to cos 2 theta, which is proved. After there is no problem to understand the solution of question number 33. If you have any doubt, then write into the live chat box, which is open to all of you. I will try my level best to clear your doubts. So the product of or a square is depend upon the formula sin 2 theta and cos theta, cos 2 theta. If you have proper idea about sin 2 theta and cos 2 theta as well as the product of two matrices, then we have no problem to solve this question. Let's see question number 34. If matrix A equal to this one, matrix B equal to this one, and x square equal to minus 1, then show that A plus B whole square equal to A square plus B square. Let's see the solution of this question. So we find out here A plus B Order of A is 2 by 2 and order of B is also 2 by 2. Therefore, addition of A and B is possible. So we write down here 0 plus 0 equal to 0, x plus 1 equal to x plus 1 and minus x plus 1, 0 plus 0 equal to 0. Therefore, A plus B whole square equal to A plus B into A plus B. Therefore, this one will be 0 x plus 1 and here will be minus x minus 1 and this is the 0. Again 0 x plus 1 minus x minus 1 and this is the 0. After the multiplication we get here first row along first column we multiply the corresponding element, then we get here 0 and minus plus minus here will be x square minus 1. Observe there is no problem to understand up to this step. First row along second column for the second element of the first row we multiply the corresponding element. So 0 into minus x minus 1 equal to 0 plus minus x minus 1 into 0 equal to 0. Therefore, we write down here 0 plus 0. Observe there is no problem to understand up to this step. Second row along first column, then x plus 1 into 0 equal to 0 and 0 into x plus 1 equal to 0. So we write down here 0 plus 0. Second row along second column for the second element of the second row we multiply the corresponding element. So x plus 1 into x minus 1 equal to x square minus 1 and this is the minus. So we write down here minus x square minus 1. 0 into 0 will be 0. Observe there is no problem to understand up to this step. So here will be minus x square minus 1 0 and this is the 0 and this is the minus x square minus 1. From question it is clear that x square equal to minus 1. When we putting the value of x square equal to minus 1, then here we get minus 1 equal to minus 2 into minus equal to, we write down here 2, and this is the 0. Here will be 0 and here also will be 2. Observe there is no problem to understand up to this step. Therefore, a plus b whole square equal to this one. Now find out a square. For a square we write down here 0 x and this is the minus x and 0 into, we write down again 0 x minus x, and this is the 0. Order of this one is 2 by 2. Order of this one is also 2 by 2. Therefore, the product of a and a is possible. So, the product here will be first row along first column. Then we get 0 into 0 equal to 0, minus x into x equal to minus x square. So, we write down here minus, or we write down here 0 minus x square. Observe there is no problem to understand up to this step. First row along the second column, to get the second element of the first row, we multiply the corresponding element. 0 into minus x equal to 0, minus x into 0 equal to 0. So, we write down here 0 plus 0. Second row along the first column, to get the first element of the second row. So, x into 0 equal to 0, 0 into x equal to 0. So, we write down here 0 plus 0. Second row along second column, for the second element of the second row, then x into minus x, then we write down here minus x square plus 0 into 0 equal to 0. Observe there is no problem to understand up to this step. So, here will be, now we putting the value of x square equal to minus 1. So, here will be minus x square, it means that 1, and this one will be the 0, and this one will be the 0, and minus x square equal to 1 plus 0 equal to 1. Therefore, a square equal to 1001. Similarly, we find out b square. B square equal to, we write down here 0 1 1 0 into, we write down here 0 1 1 0. The order of this one is 2 by 2. Order of this one is also 2 by 2. Therefore, the product of b into b is possible. So, here will be first row along the first column, to get the first element of the first row, we multiply the corresponding element. Then we get here 0 into 0 equal to 0 plus 1 into 1 equal to 1. So, we write down here 0 plus 1. First row along the second column, we get the second element of the first row. we multiply the corresponding element. Therefore 0 into 1 equal to 0 and 1 into 0 equal to 0. So we write down here 0 into 0. Observe there is no problem to understand up to this step. Now second row along the first column, to get the first element of the second row we multiply the corresponding element. 1 into 0 equal to 0 and 0 into 1 equal to 0. Second row along second column, to get the second element of the second row we multiply the corresponding element. 1 into 1 equal to 1 plus 0 into 0 equal to 0. So we get here 1 0 0 1. So a square plus b square equal to, here will be, now putting the value of a square, which is 1 0 0 1 plus we write down here the value of b square is also 1 0 0 1. Order of a square is 2 by 2. Order of b square is also 2 by 2. Therefore addition of a square and b square is possible. So we add the corresponding element. 1 plus 1 equal to 2, 0 plus 0 equal to 2, 0 plus 0 equal to 0 and 1 plus 1 equal to 2. So from working it is clear that a plus b whole square equal to a square plus b square. So we write down here, therefore a plus b whole square equal to a square plus b square. Observe there is no problem to understand the solution as well as the explanation of the solution of this question. If you have any doubt to understand the solution as well as the explanation of the solution of this question, then without any hesitation write into the live chat box, which is open to all of you. I will try my level best to clear your doubt. Let's see question number 35. Verify that a square equal to identity matrix when a equal to element of the matrix A along first row is for R 0 1 minus 1, along second row 4 minus 3 4, along third row 3 minus 3 and 4. Order of the matrix A is 3 by 3. Let's see the solution of this question. We find out a square. So we write down here a square equal to a into a. So order of a is 3 by 3. Therefore multiplication of a into a is possible. Equal to, we write down here 0, 4, 3, 1, minus 3, minus 3, minus 1, 4, 4. Into, we write down here again 0, 4, 3, 1, minus 3, minus 3, minus 1, 4, and this is the 4. So here will be first row along first column. To get the element of first row, we multiply the corresponding element. So 0 into 0 equal to 0, 1 into 4 equal to 4, and minus 1 into 3 equal to, we write down here minus 3. Observe, there is no problem to understand up to this step. First row along second column, we multiply corresponding element to get the second element of the first row. Then 0 into 1 equal to 0, 1 into minus 3 equal to minus 3, and minus 1 into minus 3 equal to, we write down here plus 3. Similarly, for the third element of the first row, 0 into minus 1 equal to 0, 1 into 4 equal to 4, and minus 1 into 4 equal to minus 4. Observe, there is no problem to understand up to this step. We repeat same for the second row along first column. To get the first element of the second row, we multiply the corresponding element. So 4 into 0 equal to 0, minus 3 into 4 equal to minus 12, and 4 into 3 equal to 12. So we write down here plus 12. Similarly, second row along second column, we get here 4 into 1 equal to 4, and minus 3 into minus 3 equal to plus 9, and 4 into 3 equal to, here will be minus 12. Observe, there is no problem to understand up to this step. Again, second row along third column, then we get here 4 into minus 1 equal to minus 4, minus 3 into 4 equal to minus 12, and 4 into 4 equal to plus 16. Observe, there is no problem to understand up to this step. Now consider for the third row. So third row along first column, this one will be 3 into 0 equal to 0, minus 3 into 4 equal to minus 12, 4 into 3 equal to 12, so we write down here plus 12. Again, third row along second column, to get the second element of the third row, 3 into 1 equal to 3, minus 3 into minus 3 equal to plus 9, and 4 into minus 3 equal to minus 12. Observe there is no problem to understand up to this step. So third row along third column we multiply the corresponding element to get the third element of the third row. 3 into minus 1 equal to minus 3. Minus 3 into 4 equal to minus 12 and 4 into 4 equal to plus 12. Observe there is no problem to understand up to this step. Let's see once again. 3 into minus 1 equal to minus 3. Minus 3 into 4 equal to minus 12 and 4 into 4 equal to here will be 16. Observe there is no problem to understand up to this step. So the here next step will be a square equal to, we write down here, four minus 3 equal to 1. Minus 3 plus 3 cancelled out, so we write down here 0. Plus 4 minus 4 cancelled out, therefore we write down here 0. Minus 12 plus 12 cancelled out, therefore we write down here 0. 4 plus 9 13 minus 12 equal to 1. Observe there is no problem to understand up to this. Minus 4 minus 12 equal to minus 16 plus 16 equal to 0. So we write down here 0. Again minus 12 plus 12 cancelled out, then we write down here 0. 3 plus 9 equal to 12 minus 12 cancelled out, then we get here 0. Again minus 3 minus 12 equal to minus 15 plus 16 equal to, we get here 1. Observe there is no problem to understand the up to this step. So from working it is clear that A square equal to identity matrix, and for this we write down here identity matrix. So this is verified. Observe there is no problem to understand the solution of question number 35, which is very easy question. If you take the proper patience, then we easily solve this question. If you have any doubt about the solution as well as the explanation of the solution, then write into the live chat box, which is open to all of you. I will try my level best to clear your doubt.